Hello, everyone. Welcome to today's live webinar, Concrete Systems 101, an introduction to insulated concrete forms and precast concrete. My name is David Meyer, and I'm a market manager for Continental Cement Company. Continental Cement is a member of many of the trade associations who are sponsoring the Sustainable Structures webinar series. The Sustainable Structures webinar series was developed cooperatively by Cast in Place and Precast Concrete Associations from the Midwest region of the United States, including Iowa, Kansas, Minnesota, Missouri, Nebraska, North Dakota, South Dakota, and Wisconsin. The goal of the cooperative effort is to bring a greater awareness of the sustainable and resilient nature of concrete building systems to the design, construction, and development communities via quality continuing education programs. Today's webinar is the second in a series of 5. I invite you to join us again next week for webinar number 3, Resiliency/Consideration Beyond Code Requirements, will be presented by Shaman Rashid Sumar from the National Ready Mix Concrete Association. That presentation has been approved for one AIA Learning Unit-HSW. Before I turn things over to our presenters, Micah and Randy, I need to go over a bit of housekeeping. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the GoToWebinar control panel that should be located in the upper right-hand side of your screen. You can submit your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of the presentation. You can also download a PDF of the presentation via the handout section on the attendee panel. A copy of the handout and a recording of the presentation will also be posted to the webinar archive on the PCI Midwest and Minnesota Concrete Council websites after the presentation. Attendees who have fully participated in today's webinar will be issued a certificate of attendance for 1 professional development hour or 1 AIA learning unit. A link to the certificate will be emailed to you within 10 business days. If you provided your AIA number when you registered, your attendance will be reported to AIA electronically. The course description and learning objectives were listed in the registration process, so I won't take the time to read them now. I'm sure Mike and Randy will cover every one of the learning objectives and then some. Remember, again, we will answer questions at the end of the presentation. I would like now to welcome and introduce our presenters. Micah Garrett is COO of Build Block Building Systems and Chair of the Insulating Concrete Forms Manufacturers Association's Education Committee. The Insulating Concrete Forms Manufacturers Association is the North American nonprofit trade association for the insulated concrete form industry and was founded in 2014 by a dedicated group of manufacturers with a shared interest of improving the quality and acceptance of insulated concrete form construction. Randy Wilson is Director of Architectural Precast Systems at PCI. Founded in 1954, the Precast Pre-Stressed Concrete Institute is the technical institute and trade association for the precast pre-stressed concrete structures industry. Micah, thanks for helping us out today. I'll turn it over to you now.
Fantastic. Good morning, everybody. We've got a few minutes here today to talk about an introduction to insulated concrete forms, and I just want to thank you all for the opportunity to give this presentation and chat a little bit about this technology. We've got a few minutes here this morning, so we're going to dive right into it and get started. All right. Just to introduce the Insulated Concrete Forms Manufacturing Association, or the ICFMA. We were formed in 2014 by a dedicated group of manufacturers with basically the goal of improving the quality and acceptance of insulated concrete form construction. And so there's a total of 6 member companies that have come together at this point in time, and our goal is to continue to grow the acceptance of insulated concrete forms and to continue to promote that in the industry. The member companies that participate currently in the ICFMA are listed here below. Feel free to contact any of these manufacturers. We are all participants. The companies listed here today are Quadlock, Nudura, Logix, Superform, Build Block, and also Fox Blocks. Everyone produces great quality products, and we're all banded together here to talk about ICFs and to continue to promote that technology in the marketplace. So what we're going to do today is just talk about a couple basic topics. One, I just want to introduce insulated concrete forms to everybody, making sure that you have a basic understanding of the technology and how it works. Second, we're going to talk about a couple of the benefits of ICF construction and kind of talk about what those are and how they relate to some different industries. We're also going to talk quickly about how ICFs are installed, just to give you a quick overview of that, and also talk about some applications for ICF and how it's currently used in the marketplace. So to get started here, let's jump into objective number one. What are insulated concrete forms? So insulated concrete forms, and I'll use the term ICF interchangeably here. These are interlocking expanded polystyrene foam blocks. So basically, I like to think of them as Legos for adults. You have two foam panels on either side that are connected by usually a plastic web. You stack these up in the shape of typically your exterior walls or demising walls. And then you're going to place steel reinforcement or rebar inside of the blocks, and then you're going to pour concrete. So what this leaves you is a structural reinforced wall that is doubly insulated on both sides. The forms take the place of traditional forming systems, and so you have a system that is going to be stay in place here. Basically, all of these are sized for different core thicknesses. So typically you're going to see concrete sizes of 4 inches, 6 inches, 8 inches, 10, and 12 inches. And some systems also allow you to do different core thicknesses in varying amounts depending on your specific needs. And as mentioned, again, you're going to place your steel reinforcement in this and you're going to fill it up with concrete. An ICF wall, it completes many different tasks at the same time. So as we kind of talked about, this is, again, a stay-in-place forming system. And so it takes the place of traditional forms that you would remove after a pour. You have a structurally reinforced concrete wall. So the rebar fits in on the plastic ties, and most of the time those ties function and take the place of having to tie all of those individual rebars by hand. So you can snap those in place, and that saves some time and labor. Also, how an ICF kind of cures and sets up, it functions with the foam as a continuous air barrier. You also have continuous insulation on both the inside and outside of the wall. And EPS foam is tested as a vapor retarder in most cases. And so depending on the specifics of the manufacturer, it's going to perform typically as a class 2 vapor retarder. So you don't need any house wrap, or you don't need to have a vapor retarder on top of that outside surface, and you don't also need an air barrier anywhere in the system. The system also has the plastic ties, which work as embedded furring strips, and so you have attachments both on the inside and outside of that wall to attach your finishes and also attach interior finishes like sheetrock, for example. ICFs also have a low sound transmission rating, often rated up to about a 54 with a 6-inch wall, and ICF walls are also well known for their fire ratings, typically rated between 3 and 4 hours. ICFs are also well adopted in the code, and so we are adopted in the IBC and the IRC. When you're looking at other acceptance criteria, we're also looking at some different standards that are tested and analyzed. Most often, companies will have an individual third party, a company that will evaluate the products and will test the products for certain standards that need to apply to specific code standards. So if you have questions about any type of code or code processes that you need for your specific build, individual companies can provide you that information. So what I want to do now is just kind of talk about some of the largest benefits of ICF construction, and some of you kind of may be familiar with a few of these types of things. One of the biggest things that we often talk about with ICFs is the fact that you have a system that is extremely disaster resilient. We're building solid mass walls that are reinforced with steel, and these systems are able to resist extreme wind loads. They're able to resist, and they have a high fire rating, and we have multiple test cases where we have ICF structures that have survived hurricanes and survived really big high wind events. You all may be familiar with this shot. This was from a project that was built by Nudura. This was on Mexico Beach, and was with Hurricane Michael. This house took a direct hit from Hurricane Michael. You can see the destruction that took place around this building. But this is an ICF structure that basically survived a direct hit. And so when you engineer with a system, you're really trying to build structures that are going to be able to last and survive extreme events. And so this is just one test case that we like to mention. And I'm sure that the owner of the house behind this one was extremely happy that they built with ICF, because that's the only reason it survived. Here's another use case. This is an event where an ICF structure survived a direct hit from Hurricane Sandy. This was a Logix project. You can see the destruction that happened to the house next door, but the ICF house was able to basically weather that storm with minimal damage that happened to the structure. Here's also a picture of some wildfires that happened outside of San Diego. These are 3 houses that are built using ICF. And you can see how when you can really enclose the building envelope and seal it up, and your walls are rated to a 3 and 4 hour rating, your structures are much more likely to be able to survive these types of extreme events. And so this is something, just as an industry, we really try to promote. We try to promote disaster resilient construction, and we've tried to provide solutions to builders in varying ranges to be able to build structures that are going to last and survive extreme events. The other component that we often talk about with ICFs is really has to do with their performance and their thermal performance. A couple of years ago, back in 2018 and 2019, the ICFMA commissioned a study with a research lab in Canada called CanBest to do a series of hot box tests to basically compare the performance of an ICF wall against several different cavity style constructions. We compared everything from a 2x4 construction with R14 insulation to looking at wood frame construction, 2x6 wood frame construction with R20 bat insulation, and also R5 continuous insulation on the outside. And we also did the same with a steel frame construction. And what we looked at was basically how that wall performed in comparison to these other types of systems. What we found is that an ICF wall at steady state performs at an R value basically at an R23, but there's also some very interesting things that happen as that wall transitions to steady state in a hot box setting. And to quickly show what a hot box basically is, if you're unfamiliar with that, basically it's a chamber, and you divide that chamber on 2 sides. And so you have a controlled setting, a control side, and you have an environmental side. And the wall sits in the middle of that, and you look at the amount of energy that transfers between those 2 sides, and it allows you to get a couple calculations out of it. One of the main walls that we were really interested in comparing it to is basically a 2x6 wall with R20 bat insulation and an R5 continuous insulation on the outside. You can see how this model was kind of put together on this specific side. What we wanted to see is basically how it performed. This 2x6 wall is built to one of the highest code standards in Quebec. And so one of the things we wanted to compare is how an ICF wall performs against one of the highest quality wood walls in the marketplace. What we basically found is that an ICF wall really transitions to steady state in a very slow, gradual way. Looking at a wood wall, you'll see that this is the red line on top. You'll see that it very quickly starts to move towards steady state, and it starts to take a lot more energy to be able to control the temperatures. So basically, if you look between these two lines, you'll see between the green line and the red line, the amount of energy that is being used to be able to keep the control side of a hot box at a steady position. And so as a direct comparison, the ICF wall is well outperforming a wood wall in this scenario. It also takes the wood wall about 54 hours to get to steady state, whereas the ICF wall takes over 6 days to get to that point. So during an extreme weather event, an ICF wall is going to outperform any type of cavity construction over that longer period of time. And to kind of illustrate that time to steady state for all of these different types of categories, you'll see here that a basic 2x6 wall with just R20 insulation, it only takes about 4.8 to 5 hours for that wall to move to steady state. A steel wall takes about 6 hours or 5.9 hours versus an ICF concrete wall takes a tremendously longer period of time to get to that point. So for us, this was some really fascinating research, and it's something that we've tried to continue to talk about in our industry, just looking at the overall performance of an ICF wall in comparison to other types of technologies. And I'd encourage you guys to research this some more and learn about some of these features. But at the end of the day, what this really means to the owner of that building is that you're going to save a tremendous amount of money on your heating and cooling bills. It's going to help with your overhead costs to be able to maintain that structure long term. And so you're building a building that is designed to last. It's designed to resist extreme events, and it's going to perform thermally at a very high level in comparison to a lot of other styles of construction. So to kind of move on to the next phase of this conversation, I want to just give you guys kind of a quick overview of ICF installation and just how ICF forms are assembled and put together. A lot of what you're going to see here today is going to be a little bit more residential focused, but the basics will apply to a commercial setting also. And so this is just kind of to give you a foundational view here. So how ICFs are installed is traditionally you're going to install ICFs on some kind of poured footing or pier or something that you've already gotten in place, your foundation wall that you're going to build up from. You're going to start at your corners. You're going to lay those out, and then you're going to start basically infilling the walls to a central point. And so you'll place your straight forms as you kind of move to what we would consider a common seam, or occasionally your blocks will actually align up with a specific dimension. ICF blocks are very easy to cut, and so you can basically cut to fit them to any size that you specifically need. Once you get your first kind of course laid out, you're going to put your steel in place, and then you're going to continue up with your next layer. Once you've gotten your first two courses done, from there, you're going to kind of square your walls. You're going to make sure everything's in the right position. And then you're going to use just a little bit of spray foam to secure your walls to your footing. And at that point, you're ready to continue on up your wall. As you install the blocks, it's very important that you create a running bond. So on most manufacturers' corners, you have a short side and a long side. So every time you're going to flip the corners, and this creates an interlock between all of the blocks between courses. And so this is just a pretty simple little graphic to illustrate how all the blocks tie together and will line up as you kind of continue on up your wall. ICFs also support a lot of different rebar layouts. And so depending on the specific engineering or qualifications for your project, you can lay out your rebar in multiple different configurations. So this illustration just gives you a basic understanding of all of that. You'll see that most of the time you're going to have horizontal bars each course or every other course, and then you're going to have vertical bars that are placed into the wall once you have your wall stacked up. And you can basically lay these out so that you can build basic chases to drop your vertical bars into place, and allows you to do all of the rebar placing with very minimal tying, making it a very fast and efficient way to install the product. There's also several different ways to finish out your doors and openings. This is a very common question about the system. Many manufacturers have EPS buck systems, so they actually have a foam product to finish off their walls. Or it's very common to use wood bucking in most situations to basically frame out your doors and windows. Also, as part of the system, typically you're going to install walls with some kind of bracing system. There's many different ICF bracing systems out there and a lot of different applications for different sizes of structures. So depending on your specific needs, you may need a tall wall application, or your bracing system may need to align with a masonry style bracing scaffolding system. There's a lot of different resources out there to be able to get your project built. But what an ICF bracing system is going to do is it functions as an alignment system. So once you get your wall stacked and secured, this works as a platform for you to continue building up your wall. And then once your concrete is poured, you're going to use the system to basically plumb and straighten your wall, so you have a nice finished wall that is nice and straight. There's also many other ways to attach to the block. So depending on your specific needs, there's going to be different penetrations or different systems that allow you to create embedments. So depending on what you're trying to attach to the wall, how you're doing your floor systems, or how you're doing your other mechanical systems, it's best to do a little bit of pre-planning before you get to the concrete phase, so that you ensure that you've made all the penetrations and things necessary to get through that wall. It's no fun to have to go back and core that wall to make penetrations for anything mechanical or to do other types of things. This is also an area where lots of people have questions, and so depending on the type of system that you're trying to use with your building, there's a lot of technical resources that manufacturers have put together. Just a quick little overview of how concrete is poured. Traditionally in the industry, you're going to pour this in 4-foot lifts. And so you'll start in one place. You'll basically walk around the complete structure pouring 4 foot, and then you're going to immediately start your second lift. And you'll continue up to the full height of your wall, and you'll finish all of that in one single day or one single set of pours. Typically, you want the concrete running a little bit out ahead of you, and so you'll want to kind of manage your slump and manage how all of that goes together. And again, anything that you want more information on, we'd be more than happy to help and give you some additional resources. So kind of just to wrap this up and to give you a little sense of what you can do and build with ICFs, we wanted to just quickly review a couple applications for ICF construction. ICF buildings, they're really not limited into what they specifically can do. They're useful in residential, in multi-story, built commercial, institutional, hospitality, churches, theaters, industrial, agricultural, safe rooms. Basically, you name it, there has been something that has been built out of ICF. And so there are tons and tons of applications, and it's a very flexible system to be able to build whatever you can imagine. So there's multiple different use cases of this being built in the multifamily setting. It's a wonderful, wonderful use in this specific situation, especially for the ownership and management group, just because of how energy efficient and how quiet these buildings are. You can really have a nice product that you can put out to your clientele, and people really appreciate the qualities that ICFs can give to this specific market segment. Hospitality, many hotels and areas are built out of ICF construction. institutional. There's been multiple different schools and net zero schools that have been built using ICF technology, and so it's a very popular way to hit this specific market segment. Also, medical facilities, hospitals, churches. This is a very popular area also, and commercial. Definitely, it's a great application for those that are going to own this building long term and make a return over a longer period of time. And industrial and agriculture. So I know this is pretty short and sweet. Again, if anyone has any additional questions about ICF technology or about anything that I've talked about today, please reach out. I'd be happy to respond or field any questions or help direct you to any folks who can. And so here's my contact information. Feel free to take that down. I'm sure that they'll give this again here at the end of the presentation, but you can find me or email me and please. Anyways, I really appreciate your time and attention today. We're going to turn this over to Randy, and I'm sure he'll have a great talk for you guys to listen to. Randy?
Thanks, Micah. That was an excellent overview of a fantastic product. You did a fantastic job, by the way. So thank you to everyone to attend today. This program about precast concrete is an overview of precast concrete products. And it's a condensed version of a much larger presentation. So I encourage you to visit our website at pci.org. There you can find a plethora of information about precast, and also you could find a local precast producer that could assist you to learn more about the products and also assist you on your any particular project that you may be considering to be using precast concrete on. So we'll get started here with our learning objectives. So today's presentation, we will identify the different precast concrete components, applications, and systems. We will also demonstrate how precast concrete is made and learn how precast concrete contributes to design versatility, energy efficiency, and long-term building performance. Now, I think this quote really kind of sums up where we're at in the build world today, and that is, as an architect, you design for the present with an awareness of the past, for the future of which is essentially unknown. This built environment we live in and we try to adapt to is ever changing. Just think 12 months ago, we had no idea that a pandemic would change every aspect of our lives. But if we go back a little bit further, we look at natural and man-made disasters, technological advancements, and the realizations of how our buildings impact our environment, and how all of that has contributed on how we build today, and has highlighted the importance of building high-performance structures with high-performing materials moving forward. And to define what a high-performance material is, or a high-performance structure, it's one that integrates and optimizes on a life cycle basis attributes like strength, functionality, and durability, along with the ability to integrate easily with other systems, be sustainable, be resilient, and be versatile. So as we go through the presentation today, I'm hoping that we can help define for you how you can take advantage of precast concrete's high performance characteristics. So one way is that there's over 250 PCI certified plants across North America that produce a wide range of precast concrete products, including architectural precast, structural precast, bridge or transportation products, precast for pavement applications, utility and underground products, and more. So for today, we're going to focus on architectural and structural precast components and their use. That'll help kind of simplify the message today, especially this being primarily an overview. Architectural precast is simply defined as any precast elements with an architectural color, texture, or finish. It can be a structural element or a facade panel. These panels can be solid concrete, insulated panels, load-bearing, and they come in just any shape imaginable. The only limitation is your imagination and the size and weight that we can haul on a truck. Now, structural units are components that carry any load and typically are categorized as wall panels, columns, beams, floor systems, stairs, and risers. I think we all are familiar with concrete, but what I want to point out is that concrete used in precast applications is a high early strength concrete, and it also includes additives to accelerate the curing process, resist the effects of freeze-thaw, and it can reach high compressive strength, especially in structural components with long span members. So back to defining precast, right? I know I'm kind of talking in a circle, but precast concrete is simply defined as a concrete component that are cast in a specific shape at a location other than its in-service position. For example, off-site in a controlled manufacturing facility that follows a strict quality control process. This allows for year-round production with very few interruptions to your project schedule. So how does a precast plant work? I think this is kind of important for people to fully understand, especially when you're starting to consider products for a project. There are a lot of moving parts and independent departments from project procurement to finished products in a precast plant. Every department supports the fabrication floor or the casting beds. So going around this circle, you can see that each department must be precisely choreographed and must be fully collaboration to ensure the just-in-time delivery of the product. So starting with engineering, all right? So shop drawings are the responsibility of the precast producer. Each precast piece is identified, it's engineered, and it's detailed, and it's checked before production. The wall panels are produced on large flat beds, some on long line steel beds, others in custom wood molds. But every plant is different, so it is advisable to proactively visit a local precast plant to get a better understanding of their specific production process. And structural products are typically produced from standard steel molds. These molds are pre-designed for the individual product that is being produced and range from 100 foot up to 500 foot long. The photo on the right is a 15-foot wide by 300-foot long wall panel mold. And on the left, you can see a double T floor system mold that is about the same length, 300-400 feet long. Now, the cross-section of these molds are fixed, but the individual piece lengths are adjustable to meet the project demands. Now, moving back over to custom architectural casting beds, they typically start with a large flat bed, usually 40 to 60 foot long, 12 to 15 foot wide. The panel molds are custom built to just about any shape, size, or configuration, as you will see in some of the project examples. But once the mold is complete, cast-in items such as thin brick, stone, terracotta, along with reinforcement, blockouts, electrical conduit, backforming, etc., are all inserted. Now, architectural components are poured exterior face down. So when the form is ready and inspected by the quality control technician, the concrete face mix is prepared and poured into the mold. In most cases, architectural precast panels are produced with a face mix and a separate backup mix. The reason is that the backup mix is typically not exposed to final view, so the producer can use a less expensive concrete mix than the exposed or the architectural face mix. Now, once the concrete is poured, the upside of the form, in most cases, the back side of the panel, will need to be finished. For unexposed units, a simple wood float or leveling float is required. However, if the back finish is exposed to final view, the designer will need to specify a finish treatment like a broom finish, a steel trowel finish, or maybe a USDA approved finish for food production facilities. Now, depending on the product being produced and the mix design required for that particular product, the concrete is designed to cure in 18 to 12 hours. Once it is reached, 8 to 12 hours. Once it has reached the minimum compressive strength, the units can be removed from the forms and moved to the finishing storage area. Architectural precast can be finished one of several ways. And in many cases, multiple finishes can be applied to the same panel to provide unique visual interests accomplished only with precast concrete. Well, once finished, the products are moved from the storage area and they're loaded onto trucks and they're shipped to the site. And once on site, the products are installed onto the building directly from the trucks without the need for any type of laydown area. Now, every step of the process must follow PCI's quality control program. Every PCI certified plant receives 2 unannounced audits each year by a third-party engineering firm that specializes in precast concrete production methods. The program includes inspecting and documenting every step of the production process from raw materials to final installation. Now, the basis for the audits are included in the PCI's body of knowledge. These manuals describe the production processes to follow when producing quality precast concrete products and can be found at our bookstore online at pci.org. So now we have a general understanding of how precast is made. Let's look at those individual components and how they're used. Precast columns and beams are made to specific sizes and lengths to meet your project structural demands. To give you an idea of their capabilities, columns can be as high as 3 stories tall, and beams can routinely stretch out to 30+ feet long. Double T's provide an excellent roof and flooring units because they can span considerable distances. These long spans will expand a designer's options for floor layouts, reduce the number of columns required, and will expedite the construction process as compared to traditional methods. And as the same as Double T's, hollow core planks can span long distances and they can be erected very quickly. And compared to traditional wood floors, they provide acoustical and impact dampening and strong fire resistance. Wall panels are extremely versatile and offer tremendous design flexibility. Shown are vertical load-bearing wall panels that encapsulate continuous insulation. The panel and insulation thickness can vary based on the project's structural needs and the R-value requirements. Horizontal panels are typically called spandrel panels because they span from column to column. This allows the engineer to transfer the loads directly into the structural columns and reduce the load on the perimeter beams. Now, earlier I mentioned that custom forms can be constructed to justify just about any size, shape, or configuration. And this project kind of exemplifies that. PCI producers are expert mold builders that can bring most any vision to life. So I definitely encourage you as an architect designer to work with a precaster early to fully understand what their capabilities are and how you can incorporate your vision into your next project. Glass fiber reinforced panels are gaining in popularity because of their lightweight. The best way to describe them is a thin skin of concrete attached to a steel stud frame. Not all precast producers produce a thin wall product or a GFRC panels, and in many cases, a solid precast panel is a more economical or better choice based on how the mass of solid concrete contributes to the overall structure's performance. Most elevated or vertical components for bridges, whether for pedestrian bridges or transportation bridges, can be produced using precast concrete girders, box beams, abutments, deck panels, and other components. So now we've taken the next step, right? We've looked at production, we've looked at some of the different components, and now let's kind of put them all together into total precast systems. There are 3 basic precast structures available: rigid frame, interior shear wall, and an exterior shear wall. A shear wall system uses interior or exterior shear walls in either a horizontal or vertical orientation, along with columns, beams, double T's, and stair towers to form the entire structure. Now, when we switch over to a rigid frame system, all lateral loads are transferred to a moment-resistant frame that ties beams and columns together with rigid connections. In this case, the need for shear walls is eliminated. And actually, the exterior panels are serving triple duty here. It is your structure, it is your enclosure, and it's your architectural appearance. And when you use a fully insulated panel, it could be your interior finish also. Now, switching over to architectural precast, it's truly one of the most versatile mediums available today because its adaptability to any architectural style. And that is because precast is extremely fluid, it's very flexible. So the precast can be produced in diverse colors, just about any color under the sun, adding additives and aggregates. You can provide it with different textures, as we saw before. And then the shape and the configuration is adaptable to just about any geometry or any form that we can create for you. Casting masonry products into precast is a great way to blend the benefits of precast with the traditional appearances of masonry. It's one of the most popular aesthetic features of architectural precast today. And the process is simple. A form liner is laid down on the bottom of the mold, the thin masonry component is placed in the liner, and then the concrete face mix is poured. And all the other production steps we've just talked about are the same as far as stripping it from the mold, finishing the panel, and then having it ready to go to the job site. But the number one way precast concrete can contribute to a more sustainable structure is fully insulated panels. This is done by encapsulating insulation between the face mix and the back mix. The amount and type of insulation is based on your particular project needs. Now, during our more expanded presentation, we would discuss all the many benefits gained by building with precast concrete, but today I just want to touch on a few. The first would be controlled production. Okay, all products are produced in a controlled environment, off your building site in a controlled plant. This allows for tighter quality control, and it avoids major weather delays. And since 1967, PCI's plant certification program has ensured that each plant has developed and documented an in-depth, in-house quality control system. The certification process is very specific to the products being produced at each individual's plant, and it aligns with PCI's body of knowledge, which again, you can find at pci.org. To add credibility to what we've done for almost 60 years is that most organizations and government agencies mandate or recommend PCI plant certification in their specification. That's because PCI is not just an institute, it's not just an organization, it's a collaboration of a collection of producers who continually provide research and development to expand and enhance the building market. So lastly, where is precast being used? Well, I just like to use the old dad joke because I'm an old dad, is where is it not being used? So for the remainder of the presentation, we'll go through some different examples of where precast is being used. And as Mike has said with ICF, it's basically where is it not been used? Every type of building project that you can imagine has used the benefits of precast concrete in one form or another. Parking structures are typically a complete total precast structure, but as you saw in those photos, the exterior skin does not have to telegraph that it's a parking garage. Offices and corporate offices have always been a mainstay of architectural precast and structural precast systems. This project here shows a great example of how architectural precast can be used to mirror just about any traditional masonry exterior. And in a lot of cases, it can demonstrate how precast concrete can actually give you appearances that masonry can't. This particular project incorporated an F5 tornado shelter. This is a TV station in Oklahoma City, Oklahoma. The whole purpose, I guess, of a TV station is they want to stay on the air, I would assume, and they want to protect the inhabitants. So this building actually incorporates an F5 tornado shelter made out of structural precast concrete and architectural precast concrete. Precast in retail has been a big market for us for the last about 20-25 years, whether it be a national account like a Nordstrom or it be a local developer. Precast, the speed of construction for precast and the aesthetic value has been big for them to use precast. Mixed use projects, whether it's a downtown setting where you're combining office and commercial, or if you're in a rural setting where you're in retail and residential, both of those applications are fantastic for precast. Stadiums, kind of a no-brainer with columns, beams, risers, and exterior panels, load-bearing and non-load-bearing. When you got a big, massive structure like a stadium or an arena, precast speed to market is extremely advantageous. When you move to performing arts centers and your museums, where you're trying to create an iconic look for your community, precast is a great solution. Most people don't think of a K through 12 as a precast worthy application, but we're finding more and more of these, primarily because of the ability to make very tall masonry appearing panels for gymnasiums, and also for areas like fly houses for theaters, and then also incorporating those FEMA safe rooms. Universities have seen the value of precast for many years, whether it be for stadiums or it's academia or office, because precast can adapt to any architectural environment, as you see here at the University of Minnesota. Government buildings, kind of a ditto. They got the same, everyone's kind of got the same thought process. How do we build faster? How do we build more economical? But how do we build a 100-year-old structure? When most architects ask that question, the answer typically is precast. And if you're trying to maybe make it more of a high-end product, then we can cast in items like natural stone and masonry. We also look at low maintenance for precast concrete. A lot of these municipal buildings look at precast as a maintenance-free type of enclosure system, which it is, especially when you start talking about facilities like jails and prisons. Healthcare has been a big market segment for us, and I also want to tip my hat to interior precast. Don't forget to run your precast from outside to inside. And with the different colors and textures and forms and form liners available, you can really, no matter where you are in the country, you'll be able to blend precast with the marketplace. Bridges are becoming more iconic, and precast concrete has been there in many places around the country. But it's also a great application, especially for those areas that are hard to maintain. Can you imagine inspecting that bridge every few years? So in conclusion is my best advice is to call a precast concrete producer early. What you're going to get out of that is that you're going to get a team member. Precasters can help devise solutions for structural challenges specific to your project, whether it's an architectural precast solution or it's a structural precast solution. Because we know that buildings can create some unique design challenges, and with all respect, we don't always have the right answer. By bringing a precaster in early, kind of spilling your guts and opening up your heart and saying, this is what we got to overcome on this project, whether it's speed to market, it's fire resistance, it's tornadoes, etc. A precaster most likely will have a solution for you. So I hope this presentation, as fast as it was, demystifies a little bit about what precast is and encourages you to use precast on your next project. And with that, we'll go kick it back to Dave and Margaret for a Q&A session.
Thanks, Randy. That was great. I want to get Micah back unmuted here too, because we're going to start answering some questions. We've got 3 really great questions right now. And as a reminder, you can still submit questions by typing them in the questions pane in your attendee control panel. So if we've got Randy and Micah both ready here, I'm going to start with the first question, and I apologize if I pronounce your name incorrectly. Pat Mosites. It's a question for ICFs around noise. Have you tested the wall for noise attenuation or airport noise? And I know, Micah, you have commented on how quiet these systems can be. Can you comment on tests for noise transmission through the ICF walls, please? Yeah,
for sure. Basically, some of that comes down to some of the individual manufacturers that have done some testing. I am not specifically sure if anyone has done anything specific to airports. I know that there have been multiple instances where walls are tested for STC ratings. So I would be curious to probably talk to a couple of the companies and see if I could direct you on that specific question. I believe that most likely Nudura has, I think they've had a project or two looking at those types of things. I would need to look a little bit more in depth for you.
Sure, so perhaps you can reach out to Pat afterwards here. Those of us that have been in these buildings know that they are extremely quiet. So I have another question for you from Erica Winters Downey. Are there environmental product declarations, EPDs, available for ICFs?
So this is another area that the industry is trying to make up some ground. we, again, it comes down to some of the individual manufacturers. We've done a fair bit of work with another organization in the EPS side, with the EPS IA. They have done some life cycle assessment pieces that look at specifically the insulation side. And also we've worked a little bit with the NRMCA and other affiliate organizations to kind of look at the impact of the concrete side. And so there is continued movement in this specific area, especially as architects are looking for EPDs to be able to evaluate what that life cycle of the products are going to be. So this is another really excellent question, and I can try to get you in touch with those folks that have worked on some of those types of projects.
Fantastic. And just sort of as a point here, both information around noise and environmental product declarations, like you said, are a lot of times answered directly by the manufacturers. So we'll put you guys in touch with some of those, and you can look on their websites as well. But I know there's information for both of those questions. So let's move on to Jody Tietze. Again, I apologize if I'm mispronouncing last names. This one is for both Micah and Randy. Do both systems provide standard details to designers new to their system so they aren't starting from scratch? Who does the design team contact to get these standard details? Randy, you want to start off on this one?
Sure. The precast concrete really does not have standard details because of the customization of the products. The best place to go to is to your local precast producer, which you can find at pci.org. And what will happen is that a precast concrete consultant, which usually a sales engineer, will come and visit with you, review your preliminary drawings, and then start to define the level of detail that you need to show in your drawings. And in most cases, the level of detail you would need to show for a structural or an architectural precast application is a lot less detail than you would have to show for structural steel or timber framing or any other solution.
That's great, thank you.
And to piggyback on kind of the ICF side, it's kind of a similar type of situation. You'll need to kind of talk to some of the individual manufacturers. Most of us have plenty of different baseline drawings. A lot of us have applications for BIM and for just kind of getting those resources for you to get started. A lot of us also have helpful information on the design and engineering side. There's prescriptive engineering and other resources of that nature. So if you have specific questions on details that relate to your project or relate to what you're doing, definitely reach out and we can get you connected with the right folks so that you can get that information.
Great, thank you. So I've got one comment here and then another question, and I'd like to remind everyone that there's still plenty of time here. We've got about 6 or 7 minutes for more questions. So while we're handling this comment and question, please type in your questions, and we've got time for probably 2, 3, 4 more. So we have a comment from Don Thompson. Says, here's a comment related to sound issues with ICFs, the question we had previously. There have been many movie theaters built with ICFs, which required the walls between the theaters to meet THX sound requirements. One side of the wall would be potentially subjected to intense sound, while the other would need to maintain absolute quiet. I suspect those similar ICF assemblies would easily meet airport requirements. So that's a great point. Moving on to a question from Juan Marcel Guerrero. Question for Micah. The pictures shown at the beginning of the show, show how the ICF houses survived some natural disasters. The 3 surviving houses shown in the San Diego, California wildfire look almost untouched. Is it really that protective?
So what it really comes down to, and as we've kind of looked more into to how wildfires specifically work, and if you research kind of what happens in those events, you really have to be able to protect the building envelope. And so if you can keep the flame from getting inside of the structure, most of the time that structure is not going to ignite. And so specifically in the residential setting, a lot of the reasons why homes burn is because embers get into that roof system and will ignite the roof, and then the rest of the house will go. So if you can build with products that stop the flame from getting inside, such as an ICF system, and you can enclose the rest of the envelope, you can really make a structure that is essentially fireproof. And so there's some good resources and things out there, and we definitely recommend looking more into how you protect the building envelope.
That's great, thank you. Lee Shepard provided us a link going back to the sound attenuation question. I sent that out to everyone through the comments here. So I think we'll move on then. Thank you, Lee. I think we'll move on to a question from Thomas Burke. Can you provide some clarity on the cost for ICF when it's completely installed?
Yeah, I won't get too much into the pricing conversation. It's always something that comes up. I definitely recommend going and talking to a couple of the different manufacturers and seeing what that looks like. You have to be able to compare ICFs on multiple different levels and also look at what materials it allows you to take out of your standard build. And so you have a wall that is a structural wall. It takes all the insulation and does a lot of things for you at the same time. So when you're doing those cost comparison types of pieces, make sure that you're looking at what the wall does in its entirety and what materials it's helping you replace.
That's great. And this is a great opportunity to remind people that the Minnesota Concrete Council has done many webinars this last year. We recently did one on ICF construction that detailed some of the costs earlier this month. So if you go to the Minnesota Concrete Council website under Education and Archives, you'll find that presentation as well as others as well.
And reach out to the NRMCA. They also have done multiple different reports on some costing that look at some large structures in a variety of different settings. And so they've got multiple reports on that also.
Great. We got a few more coming in here. We have a question from Chuck Cox. Is there any comparative testing with alternative construction methods like SIP panels and such?
I'm assuming that's an ICF question here, Dave?
It's not clear, but I would assume so, yes.
When we did our thermal study a couple years ago, we primarily focused on some cavity wall construction and then also tried to add the steel cavity construction. We have not specifically compared it to SIPs or others. But it would be an area that the ICFMA is having some discussions about other types of wall systems to test in the future.
Great. Okay, we've got just a couple minutes left, so I want to finish with a really great question from John Lee here. And this one's for each of you independently. We'll start with Micah, and then Randy can have the last word. But can you take this opportunity to state what you think the top myth with your system is that you would like to clear up? So, Micah, what is the top myth with ICFs that you would like to see cleared up?
I think one of the top myths is that ICFs are too expensive in comparison to other types of technologies. I think a lot of people get kind of confused on what ICFs really do long term. And I just want to encourage all of you to think, and especially with the precast folks also, is that you're building structures here with a different mentality. You're building structures that are designed to last for centuries, and they're designed to hold up to extreme events. So if you take that type of mindset and take a long-term approach, a little bit of potential additional cost at the front, and most of the time what we're seeing these days is that we are just as cost competitive as every other technology out there. You need to take a longer term view on what that structure is going to do, how it's going to perform, and the benefits and things that it's going to give to the ownership group that's going to operate it long term. So I always encourage people to take a long-term sustainable view and price that out, not just at the original cost of what it's going to take to build it, but to think a little bit deeper.
You know, I'll just comment that's great when you look at sustainability and environmental impact as well. You know, concrete systems tend to get a bit of a question on initial construction, but you really have to look at the full life cycle through all phases as well. So it's true for cost as well as environmental issues. I'll let Randy wrap this up here. Again, what is the one myth you would like from precast systems that you would like to be cleared up?
Well, for those who on the call who know me, this will be real short and sweet. Not. No, everything that Mike has said was perfect. That's where my head originally went to, was demystifying precast concrete. And the environmental impact, when you talk about carbon is a big issue, but when you directly take and you compare the amount of cement content in your total structure to build a total precast structure as opposed to any other type of product, and you take it cradle to cradle, and you look at the lifetime of that building, precast concrete is one of the lowest carbon impacts on our environment. And we welcome to have that discussion with anybody. But I also want to kind of, my head goes to another spot when I said, you know, demystification really is precast salespeople. They're in this world to help you build better buildings. I've spent 15 years of my career from about 1990 to about 2005 working with architects, and the ones that brought me in early, I was able to demonstrate how they could add different types of architectural looks and feels and insulation and get rid of interior finish systems, and all the things we kind of talked about come from real world experiences. So precast concrete salespeople aren't salespeople, they are your consultant. They want to build bigger, faster, stronger. They want that new PCI Design Award. They want that product on the next album cover. So please invite them in. That's what they're there for. That's what they get paid to do, and that's what they love doing, or they wouldn't be doing it. So utilize the resources at hand, and don't just go off on your own and design something or say, I don't know anything about precast, let's use something else. No, pick up the phone and give us a call.
Great, thank you. With that, we're right at 1 o'clock, so I'd like to thank Randy and Micah and everyone for attending today's webinar. You will receive an email with a link to your certificate of attendance within 10 business days. And on behalf of all the sponsors of the Sustainable Structures webinar series, thank you for joining us today, and have a great rest of your day.